Hello dear students, now we are again here in the session where we are going to together solve the questions for JEE Advanced as for the chapter Current Electricity. As you know, we have covered the question sessions for JEE Mains, NEET, CBSE. It's time to check our test, to check our knowledge whether we are able to attempt the question for JEE Advanced, yes or no. So we are going to see first of all the question for the session. That will be the question number 1. And yeah, let me just tell you that as you know that JEE Advanced is categorized into few categories where you can see question 1 to 3 is only one correct option. Similarly, step by step you are going to see the number of questions in the different category. They are divided into different categories like more than one option correct. That is matrix match type and integer type, comprehension type. So such questions are formulated over here for you, collected for you, and we are going to solve them here. As you know, these questions are from the previous year questions and also from the sample papers, the recent sample papers. We have chosen the best questions for you and together we are going to solve it here. So now the question number 1 is that in the circuit shown in figure, potential difference between points A and B is 16 volt. This is point A, this is point B. So the potential between them is 16 volt. Let me just write it, VAB equals to 16 volt, right? Now the current passing through 2 ohm resistance will be what? They are demanding from us that they are just wanting to know from us that what will be the current in this 2 ohm resistor, in this resistor, right? Now what we have to do is we have to first of all just take the current in this circuit. We will be considering, because you can see that, let me just draw it again for you. This is 4 ohm resistor. This is a battery with potential on this side, with the bigger on this side, then again a resistor, and then smaller arm of the battery, then again a 4 ohm resistor, and then point B. This is point A. This is 4 ohm resistor. This is a 9 volt battery. This is a 1 ohm resistor. This is a 3 volt battery, again it is a 4 ohm resistor, and in this one resistor is being connected, that is a 2 ohm resistor. Now what we have to do is we have to find out the current in this arm. That means in the resistor 2 ohm. So first of all, to knowing the current, we should be just supposing the current in the circuit. Now just focus over the question over here. As you can see that current always flows from higher potential to lower potential. So from here the current will be like this, and from here the current will be like this. Now let me just suppose that current I1 is flowing from here. Say this is I1 that is flowing from here. Now if I am going to suppose I am connecting a battery over here, so that means it is a complete circuit. From here B, the current will be flowing like this here. Alright. Now because it is a one complete circuit, so that means if I1 is coming from here, definitely I1 is going here. So that means it is again I1, right? Now if it is I1, let me just suppose that from this battery current I2 is flowing. This is I2, right? Now you can see this current is coming from here, this from here. So in this particular arm that is having 2 ohm resistance, the current that will be going in this arm will be I1 plus I2, right? Now again after going from here, this current will be I2. Because I2 is going from here, I1 plus I2 is going from here, I2 will go here and I1 will go there. Like this we have divided the current in the circuit. Now we have to find out the current in this arm. So what we will do, we will apply first of all the Kirchhoff's law. Kirchhoff's voltage law, as I have told you, the two laws of Kirchhoff, that is Kirchhoff's current law and the voltage law, that means the loop law, loop rule. So here let me just using that Kirchhoff's law, and I am just applying this Kirchhoff's law in this particular arm, that is starting from point A and then going from like this like this. I am supposing the current in this particular arm. So now here the equation will become as 4 into I1 plus 2 into I1 plus I2, then minus 3. As I have told you in the lectures also, that why minus 3? Because in this arm, in this battery, the current is flowing from minus to plus. So that means we are going to consider the minus sign over here. Minus 3 plus 4I1. This is equals to what has been given? VAB equals to 16 volt. So that means this will be equals to 16. This we have considered the equation 1 for this particular arm. Now we have to apply KVL, that means Kirchhoff's voltage law, in this particular loop. So let me just consider what I have told you in the KVL. We have to consider the direction of current, and if I am supposing the direction of current like this, so here what will be the equation become? The equation will be 9 minus 2 into I1 plus I2 minus I2. So the equation will be written as 9 minus 2 into I1 plus I2 minus I2, that means 1 into I2, because I am just considering I am applying the KVL in this particular loop. So then 1 into I2, that means minus I2, this will be equals to 0, right? Now from here what I can just consider this as equation number 1 and this as my equation number 2. So then what will happen? What I can do from here is I can find out the value of 2I1 and I2 from here. So that will be 9 minus I2 equals to 2I1 plus I2, right? I have found out the value of 2I1 plus I2 from this equation. So that means 2I1 plus I2 has been equals to 9 minus I2. Let me just consider this as equation number 3. Now putting equation number 3 into 1, we will be having with us 4I1. In place of plus 2I1 plus I2, we are going to write 9 minus I2 plus 9 minus I2 minus 3 plus 4I1 is equals to 16, right students? Now what we are going to do is, I am just going to rub this equation now, equation number 1. So what we are left with now? 4I1 plus 4I1, 8I1 plus 9 minus 3 plus 6 minus I2 equals to 16. So from here we will be having with us 8I1 minus I2 equals to 10, right? 9 minus 3, 6. So we are having with us 8 minus I2, 8I1 minus I2 equals to 10. Let me just suppose this as equation number 4. Now we can see that in equation number 3 and in equation number 4, if I am going to solve for them, I'll be able to find out the value of I1 and I2. When you are going to solve these two equations, you will see that your I1 will came out to be 1.5 ampere, and by putting this 1.5 ampere into this equation, or suppose this equation, let me just put this I1 equals to 1.5 ampere into this equation, I'll be left with 9 minus I2 equals to 2 into I1 plus, that means 1.5 plus I2. So when you are going to solve for this, you will see that your I2 will came out to be 2 ampere. Are you able to see this? Okay. So I1 has came out to be 1.5, I2 has came out to be 2 ampere. Now what we have to do is we have to find out the current in this particular arm. You can see in this 2 ohm resistor, my total current is I1 plus I2. So the total current will be current in 2 ohm resistor that will be I1 plus I2, that means 1.5 plus 2, that is equals to 3.5 ampere. Okay, so now we have to check whether this is the option available in the question that has been given to us or not. So I can see that option number B has been provided as 3.5 ampere, and that must be the correct answer because we have started with the correct approach and we have reached up to the correct answer. Alright, now this was the question number 1, which is having only one correct option, which is 3.5 ampere as answer. Now we will be moving towards the next question, that will be the question number 2. Okay. So the question number 2 says that in the diagram, resistance between any two junction is R. We have been provided a figure before us, a circuit before us, and between any two junction it has been given that the resistance is R. Equivalent resistance across terminals A and B is what? We have to find out the equivalent resistance across these two terminals. Now let me just again draw this figure. This is like this. P, A, this is B, and this is Q. What we have to do is we have to find out the resistance, equivalent resistance across A and B. As you know that we have covered the finding methods of equivalent resistance in the lectures. I know you are pretty much intelligent that you will be yourself knowing that what we are going to do over here. In the question we have been given across any two junction. Let me just ask you one question. What do you mean by junction? What do you mean by junction? What is junction? If we are talking about junction, that will be a point where 2 or 3 resistance are being meeting. So in the question we have been given P and Q will be also a junction. So this is a junction because 2 resistance are meeting over here. This will also be a junction, this will be a junction, this will be a junction, this and this. These all are junctions. And among these, the resistance between any two junctions is R. So that means this is R, 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 R. This has been given. And we have to find out the resistance between A and B. What we are going to do is we are going to simplify the circuit first of all. How we are going to simplify the circuit? As you know that these two resistance, these and this, these two are connected in series because their one arm is here and the another arm is connected over some other point. So that means these two resistors are connected in series. So R plus R equals to 2R, right? Because in series we just have to add them up. So R plus R equals to 2R. Now this 2R resistance, let me just remove this because this has become our 2R resistance. So that will be like this. Now as you see that this 2R and R, they are connected in parallel because their one arm is connected at this point and their another arm is connected at this point. Suppose this is 2 resistors I am having in my hand. At one point their both arms should be meeting and at another point their another arm should be meeting. At that point we will be saying that these two resistors are connected in parallel. So that means these two arms at one point, these two arms at another point. So these two resistors are connected in parallel. So what is the formula of finding resistance between two parallel resistors? AB upon A plus B. So that means that will be 2R into R upon 2R plus R, or that will be 2R square by 3R equals to 2R by 3. So that means this resistance has now become as 2R by 3. This whole will be removed. Okay, let me just redraw this figure. In place of these wires, I am connecting resistors because we are talking about the resistors over here. Now this is point A, this is point B, this is point Q. This has become 2R by 3. This has been reduced now. Now again what you can see over here, this is R, R, R. How do we can simplify it more? Now again you can see this R and R are connected in series. Why? Because their one arm is here, one point is here, and another arm is joined at two different points. So R plus R will be equals to 2R. Now again this 2R has been connected in parallel with this R. Again the total resistance will become 2R by 3. So we can now rub this out and we will be writing in place of R, as we have found out this 2R by 3, similarly this will also be 2R by 3. Right? Now the figure has been simplified more further. We have to find the resistance between A and B. This is point B. What more we can do? We can see that these two resistors are connected in series, 2R by 3 and 2R by 3. So that means it will become as 4R by 3. When you will be adding 2R by 3 plus 2R by 3, you will be left with 4R by 3. So that means you can further simplify this circuit as, okay, this is R, and this is R. This 2R by 3, 2R by 3 has been solved as 4R by 3. So I can write this as one resistance, that is 4R by 3. Now you can see that this 4R by 3 and this R are now connected in parallel. And we know that to find out the resistance between any two parallel is AB upon A plus B. So A into B, 4R by 3 into R upon 4R by 3 plus R. So we will be having 4R square by 3 into 3 by 7R. So you will be left with 4R by 7, right? So that means this resistance we can write it as nothing but 4R by 7. Now as you can see again, these two resistors are connected in series. So that means 4R by 7 plus R. So that will be 4R by 7 plus R. Or you can write it as 7 plus 11, 11R by 7. I can just remove this and I'll be writing it like this. This is A and this is B. This is 11R by 7. Now as you can see, these two resistors are connected in parallel. So to finding out the equivalent resistance between A and B, the total resistance will now be, let me just remove it from here. The R net will be 11R by 7 into R divided by 11R by 7 plus R. So that means 11R square by 7 multiplied by 7 by 18R. So you are left with 11R by 18. This as the net equivalent resistance between any 2 points, that is A and B. So our answer has came out to be 11R by 18, and now we have to check in the options available 11R by 18. So I can see that option number D has been given as the similar option that we have found out. So this must be the correct option for the question. We will be now moving towards the next question, that will be the question number 3. Okay. So in this question, the resistor in which maximum heat will be produced is what? We have been given a circuit and we have to tell them in which particular resistor the maximum heat will be generated. Now let me just tell you one thing. To find out the maximum heat, we should know that what is the resistance, because we know that H equals to V square T by R. That means heat is indirectly or you can say inversely proportional to resistance. If resistance will be less, heat will be more. And now in this circuit, what we can see, let me just redraw this figure for you. This is something like this, and this is a 2 ohm resistor. Again, this has been connected with the 4 ohm resistor, and this has been connected with a battery. Now in this, this is 2 ohm, this is 6 ohm, this is 3 ohm, 5 ohm and 4 ohm. As you can see that these 3 resistors are connected in parallel. Why parallel? Because their one arm, their one end is connected at one particular point. This and finally this. And again the second arm is this and this. So that means these 3 resistors are connected in parallel. To find the equivalent resistance between them, that will be 1 by 3 plus 1 by 6 plus 1 by 2, or that will be 1. So that means this whole resistance has been came out to be 1 ohm, right? And again if I see this figure, these 2 resistors are connected in parallel. Again the total resistance will be AB upon A plus B, 20 by 9. So that means these 2 resistors has been came out to be 20 by 9. Now I can redraw the equivalent circuit like this. You can come with me. The equivalent circuit will be 1 ohm and this as 20 by 9 ohm. Now dear students, there is one thing that we can discuss over here. You can see that because these 3 resistors were connected in parallel. So from here we can see that because these 3 are connected in parallel, so that means voltage is definitely going to be same in these 3 resistors. So that means if voltage is same, we can judge on the basis of resistor. Minimum resistor, high heat. So in these 3, 2 ohm resistor will be having maximum heat generated. So I can write it as, here 2 ohm will be generating maximum heat, or maximum heat will be generated in 2 ohm. And in these 2 resistors, if I'll talk about these 2 resistors, this is the minimum resistor, so that means maximum heat will be generated across 4 ohm resistor. Again maximum heat will be generated across 4 ohm resistor. Now we have to tell them in these in between these two resistors, in which resistor maximum heat will be generated. Will it be across 2 ohm or 4 ohm? So that means we are left with only two resistors. We can ignore the other options. So let me just go to the options that is available for us, and we are going to deduct the options that will be departed from 2 and 4. So I can cut this option 5 ohm and I can cut this option 6 ohm. I am left with only two options, that is 2 ohm and 4 ohm. In between these two, I have to tell which one will be the correct. So I have to individually find out the maximum heat generated across them. Now consider this circuit again. This is 1 ohm resistance, this is 20 by 9 ohm resistance. As you know that voltage is going to be divided in the resistors when they are connected in series. So that means this will be V1 and this will be V2, right? Now I can say that this V1 is connected across the 2 ohm resistors, because this was the equivalent, 1 ohm resistance was equivalent for 2 ohm, right? So this will be considering as V1 and this will be considering as V2. Okay. Now what I can do is, this total resistor V has been given as capital V. Now if I'll be writing V1 upon V2, that will be V equals to IR. So because current will be same in the series circuit, I and I will be cancelled, we will be having the ratio of only R1 and R2. So V1 upon V2 will be equals to R1 upon R2, that is 1 divided by 20 by 9, or you can say that 9 by 20. Now what I can do is, I can find out the V separately V1. So that will be, if I'll be finding V1, if I'll be writing the V1, my V1 will be, say V1 is 9, V2 is 20, right? So total will be V1 plus V2, that will be 29. So V1 will be 9 by 29 and V2 will be what? V2 will be 20 by 29. Now we know that the individual voltages among them is V1 and V2 like this. To find out the maximum heat generated, I know the formula that I can apply it easily. Let me just okay. So the maximum heat generated across 1 ohm. If I am talking about 1 ohm, that means I am indirectly talking about this particular resistor that I am left with, that is 2 ohm. So because I am talking about V1, that means I am talking about the 2 ohm resistance. So across 2 ohm resistor, that will be H equals to V square T by R. So here V will be V1. So 9 by 29 whole square T by R. Your R will be 2, right? So 81 by 29 square, that will be the heat generated across 2 ohm resistance. If I talk about the heat generated across 4 ohm resistance, that will be 20 by 29 whole square T by R, that is 4. Now you can see easily that if I'll be doing the square of 20, that will be 400, and if I am doing the square of V, that is 9 over here, that will be 81. So that means definitely this is the maximum heat generated. So we can say that maximum heat is being generated across 4 ohm resistance. So among these two, in between these two, 2 ohm and 4 ohm, we can take over this 4 ohm resistor, that is the maximum heat generated is across 4 ohm resistor. So this was the question, and now we will be moving towards the next question. That will be the question number 4. Okay. So I can see that question number 4 to 5 are in the category that is more than one correct type answer, right? So in the question we have been given a circuit, and in the circuit we have to find the ratio and we have to tell them whether it is true or not, right? So in this complete circuit, I can see that they are asking to find out the I1 upon I2. If I have to find the I1 upon I2, there is a formula that we have taught you, that if we know the complete current in the circuit, the total current in the circuit, we can find out the I1 as I multiplied by R2 divided by R1 plus R2, right? So from here, total I is I, so I am going to consider this as I. Here R2 will be simple R2, I am going to write this as simple this equation, and I2 will be I into R1 upon R1 plus R2. If I have to find out the total current, that will be I equals to E upon, that means I equals to V by R. So E upon R plus R1 R2 upon R1 plus R2. Because these two resistors are connected in parallel, and along with this, one resistor is connected with series with this combination. So my total current will be looking like this, right? Now they are asking to find out the I1 upon I2, and when we have to tell them whether it depends on R1 and R2 only or I1 by R2, it depends on E, R1 and R2. So if I am going to find out the I1 upon I2, my ratio will be I R2 upon R1 plus R2 okay. So I also cancel, I am left with only R2 upon R1. Because you can see this term I has been cancelled, so that means there is no chance that E is going to be considered in this option. So we are left with only I1 by I2 as R2 by R1. So only it is depending upon R1 and R2. So I am going to tick over the one correct option, that is I1 upon I2 is depending on R1 and R2 only. Now because this is more than one correct type answer, we have to check for this also. We have to check for I by I1. Now to consider for I by I1, I can directly take this I by I1 ratio from this equation. Let me just say this is equation number 1. From here I by I1 will be equals to R1 plus R2 upon R2. In this equation also I cannot see that there will be a ratio depending upon E, R1 and R2. It is only depending on R1 and R2. So again this will be cancelled. This must be the correct option, the second correct option, and these two are definitely will be the correct option for the question that has been given. See, the question was a little, the figure was little tricky. You can say tricky, but this was the simplest thing that we can see over here. And in the exam, because I know that students get confused, if the question would be easy, they will be surprised that this question cannot be so much easy. So they are going to just run their mind in opposite direction, and definitely they are going to attempt the wrong answer. So this was the question number 4. And the question number 5, that we can see that when a potential difference is applied across, the current passing through an insulator at 0 Kelvin is 0, a semiconductor at 0 Kelvin is 0, a metal at 0 Kelvin is finite, and option D, a PN diode at 300 Kelvin is finite if it is reverse biased. Now let me just tell you, this is the theoretical question, conceptual question. So in this question what we can discuss over here, as we know that we have been classified the you can say the conductors, insulator in the very beginning of the chapter. The conductor, insulator, semiconductor, what are these? insulator will be that you can say in which no current will be flowing. So doesn't matter whether it is 0 Kelvin or whether it is 1 Kelvin, an insulator at 0 Kelvin will be flowing, the current will be flowing across it will be 0. So that means this is the correct option, right? And if I talk about the semiconductor at 0 Kelvin is 0. We know that at 0 Kelvin, a semiconductor behaves as a perfect insulator. It behaves as perfect insulator. Now you know the property of insulator, that no current will be flowing. So that means at 0 Kelvin in the semiconductor, flow of current will be 0. So that means a semiconductor at 0 Kelvin, the current will be 0. This is also the correct option. Now if I talk about the option number C, a metal at 0 Kelvin is finite. So that means they are saying that in a metal the current flowing will be finite at 0 Kelvin. But let me just tell you, at 0 Kelvin the conductors, because we are talking about the metal is a conductor. So we know that at 0 Kelvin conductor will behave as superconductor. And what is the property of superconductors? That the current flowing will be infinite. Current, that is I, will be infinite. But in the option we have been given that this will be finite. So this is not the correct option. We can deduct it. And finally the fourth option, that means a PN diode at 300 Kelvin is finite if it is reverse biased. We know that if we are reverse biasing a diode, a current will be flowing because of minority carriers. So that means some current will be flowing, a finite current will be flowing across the circuit if it is reverse biased, and if we are taking it at 300 Kelvin. So that means this will be also the correct option. So among these four options, option number A, B and D, these are the correct options. So now we will be moving towards the next question. That will be the question number 6. Okay. So the question number 6 is 6 to 7 is a matrix match type. This is a different category where you have been provided a table and you have to match them out which one will be the correct option corresponding to the options that has been given over here. So in the circuit shown in the figure, match the following. We can see that they are asking the minimum current will flow through which resistor, maximum current, then maximum power, then minimum power. So what we have to do is, we have to find out the minimum current or the maximum current. I am going to first of all draw this circuit. This as what are the values of resistance? 2, 4, 3, 5. 2 ohm, 4 ohm, this is 3 ohm and this is 5 ohm. Now in the circuit what you can see over here is that these two resistors are connected in parallel. And also we know that current is going to be divided. Suppose this is V, so say that I current is flowing through this. So current in this circuit is going to be divided into the inverse ratio of their resistances. So let me just say that the current in this arm, that just say I1. We know that formula for I1 is I into R2 upon R1 plus R2. Now here your I is I, your R2 will be 4 and R1 plus R2 is 2 plus 4. So that is 4I upon 4 plus 2, 6, or you can say 2 by 3I. So here 2 by 3I current is flowing, right? Is it visible to you? Okay. Now in this arm what we can just see, again we are going to apply the formula that will become as I into R1 upon R1 plus R2. So that means I into 2 upon 6. I into 2 upon 6. So that is, you are having I by 3 as the current in this particular arm. This is I by 3. Now in this arm again the current is going to be divided in the inverse ratio of the resistances. So that means your current in this arm will be 5 divided by 5 plus 3, that is 8I. And similarly over here the current will be 3 divided by 8I. 3I by 8. So this is the ratio of current in the different circuits. Now what I can do is, we know that we have to find the maximum current and minimum current. Now minimum current will flow through which resistance? To find out the minimum current, I have to take the ratio, this 2 by 3I, this 1 by 3. So what we can do is, this is just a simple thing. What is 2 by 3? If you are going to divide it as, you will be having it as 0.6, right? This is 0.6 ampere. Now what is 1 by 3I? Again 0.33, because I know that I cannot divide it as like this. So I am just making it sure whether I am doing it correct or not. So 1 by 3I is 0.33 ampere. Similarly, what is 5 by 8I? .62, and this will be 0.67, and 3 by 8I you can divide for this also. Approx 0.4 ampere. These all are ampere. So this is 0.67, that is 0.7 you can say approx. This is 0.6, this is 0.4, and this is 0.3, in which you can see what is the minimum current. So the minimum current, I can see that this is in this arm, 0.3. So that means this is 4 ohm resistance. Minimum current is in 4 ohm resistance. So minimum current, that means this will be A, right? Now the maximum current, you can see the maximum current is 0.67, or you can say this is in 2 ohm resistance. So that means this will be B. Now maximum power. To find out the power, we can directly apply one formula, that is P equals to I square into R. I square into R. Now to find out the power across them, we have to do the square of, that is I square 9, okay, 4 by 9 into R. Your R is 2, that is 8 by 9. This will be across 2 ohm resistance. Now power across 4 ohm resistance, that will be 1 by 3, 1 by 9 into 4, that is 4 by 9. Similarly, power across 3 ohm resistance, that will be I square, that is 25 by 64 into 3, 75 divided by 64. Now power across one last, that is 5 ohm resistance, that will be 9 by 81 into 5, that is 45 by 81. Definitely I can see that maximum power will be generated across 3 ohm resistance. So I can tick for the maximum power. Maximum power will be generated across 3 ohm, that is this C, right? Now minimum power, if I talk about the minimum power, I have to find this ratio, that will be 8 by 9. So if I'll be doing it, that is coming out to be 0.8, okay, and if I am talking about the 4 by 9, that will be 0.4, okay, and if I am talking about this, this is the maximum power, this cannot be the minimum power, and if I am talking about this, this will be something about 0.5. So I can see that maximum power is generated across 4 ohm, the minimum power is generated across 4 ohm resistance, that is 0.4. So minimum power across 4 ohm, that means this should be the correct answer for this. So yeah, this was the question, and now we have completed this question. We will be moving towards the next question of matrix match type. Okay, the question number 7. The question number 7 says that we have been given the following table in which the length of 4 copper rods at the same temperature, their diameters and potential difference has been given. Rod 1, 2, 3, 4 length, these corresponding lengths, their corresponding diameters and their corresponding potential differences across them. And we have to tell them which one will be having the greatest drift speed of the electrons between them. So to find out the drift speed, we know that we are having one formula I equals to NE into A into VD. From here, VD will be equals to I upon NE into A. Right? Now we have to, because we have to tell them this. We know that we can write this I into the form of Ohm's law, that is V by R. R. And you know that the formula for R is nothing but rho L by A. So I am going to put this value over here. We will be having V upon NE A into rho into L A. This has been cancelled, so I am left with only V by this. Now from here you can see VD is directly proportional to V by L. Now we can see that the one which will be having maximum potential will be having greatest drift speed. So I can see the maximum potential is of 3 volt and this is for the rod number 2. So that means greatest drift speed will be for rod number 2. So this will be the A. Now greatest current, again if I am talking about the current, I equals to V by R. Now V by R, again you can write this R as rho L by A. And again what we can do is, we can write this area into the form of pi R square. So because diameter has been given, we will be writing it as pi d square by rho L. So from here I can say that my I is proportional to V into d square divided by L. So the one which will be having maximum diameter will be having maximum current. So the diameter, I can see that this is having maximum diameter. And if I am going to multiply this 9 and V, I am having 9V upon L. Simple. So I am having 9V by L. But similarly, if I am just considering the voltage, maximum voltage is across this. So that means again V into d square, that means, okay, just leave this option, we are having our answer, you can correct, you can just understand up to this point also, the maximum is 3d square by L, right. So now this is of option number, this rod number 1, that means greatest current will be for rod number 1, or we can write it over B, right. Now greatest rate of thermal energy produced. To find out the thermal energy produced, we can just say that this is power generated and nothing else, or you can write it in the form of heat generated. So that is V square T by R. Again rho L by A, or you can write it as power generated is directly proportional to V into D whole square divided by L. Now, because you can see that again V square, that means one which will be having maximum potential and one which will be having maximum diameter. So, maximum potential is at this point, that means 3, and in this is the, you can say, the diameter. So, the total, you can say, the power generated across this will be, let me just say about rod 2, across rod 2, that will be V into D whole square by L. V is 9V into D square, that means 9 into 9D square divided by 2L. Now, if I just see the case of the one with maximum diameter, that means rod 1, it will be having again 9, that means I am talking about the rod number 1, that means 9D square into V, again upon. Now, we have to consider, because we know that the numerator are coming to be same, but now here we have to consider the length. The one which will be having minimum length will be having maximum power. So, here the length will be L. So, that means rod 1 is the one which will be having maximum power generated, or you can say the greatest rate of thermal energy produced. H equals to again V square RT, V square T by R. So, we have just find out that rod 1 is the one with greatest thermal energy produced. Now, the fourth option, that is greatest electric field. We know that the formula for electric field is, let me just remove this, okay, let me just write over here the fourth one. If I am talking about the electric field, we know that E equals to V by L. So, we can say that E is proportional to V by L. So, the one which will be having the maximum potential will be the one that will be having maximum electric field. So, maximum potential difference I can see is over here, that is 3 volt, or we can say the rod number 2. So, that is the D, or you can say this is the correct match of option number D. So, this was the question and this was the solution. You can take a note of this and we will be solving the next question, right.